So what is this? So I will draw a figure here. See, so at this section, we have a laminar, then we have a transition, and then our turbulent. Okay. And I will graph here the boundary layer. Say this is our boundary layer. Okay. And then say this axis is our h, our coefficient. Then this line here, from here, say this is our flat plate. Okay, so along this is our x-axis. Okay, so if say we have this graph and based from this graphical representation, we can it shows a fluid flow over a flat surface. This is our flat plate, and graph of h as a function of x. Say we have the value of our h as that looks like this. Okay. So we have a graph of our h at a certain condition, because once again the value of our h varies with the different conditions of your fluid. So we have as your fluid flows with different flow flow condition, and at a certain flow at a certain geometrical surfaces, then the value of our h changes continuously, right? So if we have this, say this kind of value of our h from this say this is our flat plate. So from this point up to this point, as up to this axis, as the fluid flow against your flat plate, then we can have a different value of h. Say this is your value of h, having this graph. So from here to here, and then here to here. Okay, say we have this kind of h, different values of h, wherein it varies along the distance x, right? And therefore at every point in the region, we will have a different value for the heat transfer coefficient h. Okay, however, we can also obtain an average value of h when we are looking at an interval. Say we are looking from this interval to this interval, from this interval to this interval, then we can now obtain the value, the average value of our coefficient h. Okay, say this, if we will gonna sum up this, we can have the can have our h average. Okay. Okay, so if we are interested only for heat transfer coefficient value at a point, say at this point, at this given x, at this given length, okay, if we are interested only for heat transfer coefficient at this point, then we term it local heat transfer coefficient. So, and we call it hx. Okay, if we are interested for the average value, say we have um, uh, considering this this what I call this entire region, then we can have our average heat transfer coefficient H, or we can write this using a symbol H dash. Okay, so that is the difference when we say local versus the average coefficient. Once again, based from this illustration, we have your boundary layer as your fluid moves or goes along the flat plate along the x direction. Okay, so at certain condition, you can have a different value of your h, because once again the value of h depends on the condition of the flow and your surface. Okay, so at this point you have a different value of h. If you are looking for the specific value of h at such point, at such given point, we term it local. And but if you rather want to have the value of h of this entire length from this to this, then you can now consider your average h, or the average coefficient. Okay, so that is the main difference between the local and average coefficient. So you need to be specific what are you looking to or referring to when you are considering or computing your h. Okay. Okay, so another thing that we must we need to know, aside from the importance of the Nusselt number and the this local and average H coefficient in in defining our heat transfer coefficient, is the what we call film surface temperature. Okay, so this film surface temperature, since various properties is a function of temperature, right? And that we have a temperature for our fluid stream, and we also have the temperature of our surface, right? The fluid stream and the temperature of our surface. Then if we will gonna evaluate the properties, we need to base our evaluation on the so-called film temperature. Film temperature. Let's call it TF. Okay. Again, since we have the temperature of our fluid stream, and we have also another temperature for the our surface. Okay, and if we were gonna evaluate if we were gonna have the evaluation of properties, we need to base this on the so-called film temperature, df. Okay, unless otherwise stated, okay, wherein this is simply the arithmetic average of your surface temperature and the free stream temperature. So mathematically, the film temperature is only the average of your temperature of your surface and fluid Yan. So, that is the so-called the film temperature. Okay, so the fluid properties are then assumed to remain constant at those values during the entire flow. Okay, so once again, we need this film surface temperature, or simply the film temperature, by having the average of your fluid stream, temperature of your fluid stream, and temperature of your surface, because we need this during the evaluation of the properties. Okay, so we need to consider this TF. So later on, you will gonna appreciate those things when we gonna have our example on how we can find this heat transfer coefficient H. Okay, so that's all, and see you on our next video.